Let's start. We're going to divide the WOOC lab into two parts, very quick part to remember what we're talking about, and then we're going to solve problems together at the end of the class.
Well, I think I just copied it from the bit.
One is in.
You can see this a bit nicer. But
So let's start. Okay,
actually, no, that's not true.
it's okay if you just answered. Look at the board and answer, even if you're not logged in. What is a MAP ADT? Again, let's just do a recap. Guys here, guys. What is a MAP ADT, guys? What is a MAP ADT? We need to remind ourselves every time about the bigger picture, about the ADT. What are we trying to do? So a MAP ADT is what to efficiently store and retrieve values based on the uniquely identifying search key. That means I'm going to have a unique key. Okay, guys? Has nothing to do with priority. That's a priority queue when I want to do stuff in priority order. Correct? So again, maps. Why am I asking about maps? Because hash tables is one way to implement the MAP ADT. Okay, what are some of the data structures that we have seen, that we learn about, which can we use to implement the MAP ADT? We've been studying maps for a while now. Okay. So 66%, 67%, all of the above. Who wants to answer why with each one of them? So why it's all of the above? Yes. Okay. We have an actual logical answer. Abed.
Regardless of the function.
What is heap designed for? We came up with the heap to do what, guys? To implement. Why did we came up with the heap? To implement which ADT? Priority queue. Why it fits the priority queue? Because at the end, you're going to either have a min heap or a max heap. That means on the root, you're always going to have the priority key that you want to take out. Because in a priority queue ADT, you're going to always choose the highest priority. Let's say your highest priority is the minimum key. That's why we build a min heap. But in a min heap, in a heap in general, let's take a min heap. The parent is what? Is less or greater than the children? Less. But are they organized from left to right? Okay, so can I search? Okay, guys. So the idea here, we chose heap to implement priority queue. And then we said I cannot use it because it's not efficient when I want to search and I want to choose something in the middle, not just from the root. So that's why we went to the sequence. Then we found in the sequence, it's good if you're using ordered, correct? Ordered array, because you can use binary search, but there is a problem. Then we said, okay, BST is good, but the worst case is what for the BST? O of n or O of log n? O of n, the worst case. Then we said, okay, we want something better. So we went to the AVL, and we said AVL, the worst case is always what? O of log n. Then, now we're explaining what the hash maps. So what is the worst case time complexity for insertions, removal, and search in a hash table? So of 1 or of n, we said the worst case is of n. Why? Because we're still using an array, and if the array is not built, if the hash map is not built correctly, you're going to end up with of n. But we said the whole idea of building a hash table is to put lots of effort in building it correctly in a good way, so that the expected time will be of constant. When would the expected time happen? When would the O of constant happen? In which cases?
You know, any problem, you just found the spot and just.
Yes, so technically if you're building your hash table, how do you keep it good? We said if it's what? If the values inside it are spread, right? If I don't have something like this, so let's say I have this. We said if I have this table, guys, and I have like a value here of 5, I don't know, then I have another value here, 15 and 16. If it's spread like this, that means my chance is usually higher to have more efficiency, to be O of 1, okay? But if my table is like this, so I have 18, so all of these things like this, for example, 20 here, what's going to happen? Or like 25. I will end up with what? 10 here, because this is, okay? So the worst case is O of n. Don't make this mistake. But if I'm building it in a very efficient way, using what? We're going to remind ourselves today, the collision functions and the hash functions. If I'm using them very well, then I'll be able to have the expected time of O of 1. Yes?
So can you say the standard integer or what is in and or how do you do this, like we do separate?
Yes, we said we're not going to, it's not going to be O of 1. When we talked about the hash maps, we're going to be talking about this one, O of n. We're not going to cover the separate chain. So I know what you mean. This is the one that have the bucket here like this, right? So this is, I'm not sure if it's still O of 1 or n log n. I'm not sure of that, but we don't cover this. What we mean is we said it's always more efficient to be like this, what's called the probing, the probe hash map. Okay. Now, let me check if we still have any other question. No. Okay, so we'll leave the WOOC lab and we'll continue it in a bit. Okay, so let's continue. Now, I updated the slides. I just took one thing here. Previously, we had an equation to calculate the average number, but this equation is not actually accurate, so I just erased it. Okay, so I just uploaded one without the equation here. When we want to calculate the average number of probes, we're going to do it manually, and we're going to see how we can calculate it. Usually, sometimes we ask you in the final, calculate the average number of probes. We're going to cover it. So the idea here, guys, we said if you're having a linear probing, so before we do that, let's go back one step. So we said if I'm using linear probing, okay, so what do I mean by linear probing? I need to have a hash function to store my keys, correct? If I'm using the linear probing and I end up by having 90% of my array is full, I'll end up with 5.5 probes to find each. So if I'm searching for a number, it will take me 5 tries or 6 tries to be able to find it. So that's what this means. That means linear probing is not a very good solution for me. Usually, I'll choose something else. I will choose something better to build my hash map. Why? The more efficient the way I build it, the better time complexity I'll have. So let's review the linear probing, which we covered already. We're going to review it again, and then we move to the quadratic probing, and then the double hashing. And then we'll solve a few exercises together. So usually, I'll need 2 things to solve any example. What are these 2 things? We said I need the hash function, and then I need a collision resolution. If I want to remind ourselves, why do we need the hash function and why do we need the collision resolution function? Why don't we have just one function? So what is the hash function for? Riley.
Have 2 different functions because they do 2 different things. So your hash function is in the spot, and then the collision resolution is if you send it to 2 items to this specific spot, and then you have to resolve that.
Very good.
Because they wouldn't do the same thing.
Exactly. Technically, if you remember, how did we start talking about the maps? What is the difference between the hash maps and the normal AVL? For example, we said usually in the AVL, let's say we're going to use the student ID, your student ID, as a key because the student ID is unique. So I'm going to use it as a key, and then inside this, I'll store your information. What is the difference between a hash map? Because we're going to use a table, can we still use the student ID as keys? If yes, why? If no, why? Ralph.
I think no, because we represent those student IDs by like integers putting them into the table.
Okay. Another answer? Riley.
So we talked about earlier about how student numbers are really long. You were making a hash table, it'd be a gigantic hash table, and it's only useful if you had actually like 1 billion students.
Exactly. So we said if I want to access O of constant, O of 1, that means what do I need to do? I need to build my data structure with an array. Why? Because only if I have the index number, I'll be able to access it, correct? So if I have an array with index numbers like 0, 1, 2, that's where I'm able to access it. So if I'm using the student ID as my key, that means I need to create a huge table to be able to fit all the student ID, to be able to fit all the student IDs. That means if I have a 7-digit student number, we said it's going to take us to build a 10 million indexes array, like an array length of 10 million. But what if some student dropped, some student graduated, so they still have this student ID, right? So it's waste of time. We said we're going to know, we need to, the idea of a hash map that we're going to generate a new key. That's the difference between other ones. We're going to generate a new key. So when you enter this class, we said, okay, Fida just entered. Instead of telling her, okay, I'm going to use your student number, no, I'm going to generate a new key and give it to Fida so she can, for example, sit or something. Perfect. Now, the hash function, guys, the hash function is what? That's the role of the hash function, to generate a new key for you to be able to be able to insert something or remove or search. And we said we're able, in this case, to minimize the array from 10 million to 10,000, for example, if we're using the modulus. Here, if I'm using the mode, whatever I put the n here, it's going to give me the length of this array. And we're going to see it. Now, this is my first function. Okay, then Riley said, why do I need the collision resolution function? Because what if I generated the same key for both? So for example, Fida, we generated key number 2, and then Riley key number 2. So both they have the same key. Then I need a collision resolution to solve this collision, so they will be able to enter or search in this table. Okay, so we need 2 things: collision resolution and hash function. In this case here, we're going to choose the hash function as this one, key mode n. N is the total number, the length of the table. Then I'm going to choose the collision resolution as what? As the linear probing one. Sometimes you're going to choose a different collision resolution, like the quadratic. And we already talked about this, correct? We said the idea of the linear probing is that we're going to have the first one, this one, and then we're going to add J, and this is J, we're going to repeat it again together. So let's take this example once again. So what is the length of my table? It's 13. I want to add 13, so what's going to happen? 13 mod 13, right? And then it's going to be 0. So where I should answer 13? At 0. Very good. Now 15. So again, I'm going to do 15 mod 13. It gives me 2. I need to answer it at index 2. Very good. So far, so good. 5, the same thing. 5 mod 13. It will end up at 5. Now 28. So what's going to happen? If I do 28 mod 13, I'll get 2. 2 is occupied. So what should I do? In this case, I'm going to go for the collision resolution function. So I'm going to put this answer here, 2 plus J. This is H0. So what is H1? 2 plus 1 mod N. Okay? So that's what's going to happen here. I'll do this. That's H28. I already solved as 2 plus 1 mod 13. That's 3. And I'll insert here as 3. So this, from a theoretical perspective, this is the theory, this is the function. But when you're doing linear probing, guys, in the exam, there is a much easier way to just do it right away without even calculating and wasting your time, because it's linear. So how can I do it? If this is occupied, I'm here, and I'm doing linear probing, that means I'm going to do just plus 1. So I'll go to the next one. I can just put, 28 right away here. Okay, so in the exam, you can just skip it. We're going to see one of the exercises. But this is the function that you're actually using under the hood, right? Yes.
Yeah, as a whole point of that function, just to try to spread out.
Yes.
The
Yes, we're going to see now what's going to happen. We're going to use the same example with the quadratic, and let's see if it's going to be spread or not. Okay. So very good. So again, that's 28 is here. So I'm done. I'll go to the 1 mod 13. It will be at 1, and then 14. So look, 14 is going to be here, okay, at 4. And then 2 here. Is this good? Look, I have this array. Now let's assume I want to add a number, and the key that I generated is 1. What's going to happen? So 1 probe, 2, 3, 4, 5, 6, 7 probes. It's going to take me 7 probes to be able to insert or search. That's not good. That's why we need something a bit better. So we're going to try the quadratic problem, which will spread it. So for example, what do we mean? Let's assume we had it like this, and the 14 was here. So that's the 14 here. If I put the 14 here now, for example. And if I want to add something at once, so first probe, second probe, third probe, 4. It only took me 4 probes to be able to insert instead of 7. So that's why if I have it like this, the arrays, like the values in the array are more spread, it's going to be what? More efficient for me, correct? Very good. And this is a proof for us. I want to add the coyote, it's 2, so I'll come here, 1, 2, 3, 4, 5. So I'll have something called primary clustering. Okay, so that's the problem. So maybe I should use nonlinear probing. So let's check what is a nonlinear probing. The only difference between linear probing and nonlinear probing is that the J here, I'm going to make it square, okay? So let's take an example. Again, I want to add 13. I already know that 13 is going to be at 0, 15 at 2, 5 here. Now I want to add the 28. And the 28 is going to be here, because why? It's going to be at 2, and then we're going to put it at 3. So let's try now the 14. So look what's going to happen now, guys. 14 mod 13, 1 is occupied. So what should I do now? Who can help me with this? And if you have a question before that, ask. It may be confusing, lots of numbers, lots of things. So ask, we have time. Is there anything confusing before this step? Yes, right.
The one is occupied.
Yeah.
I'll start my probe, so I'm gonna do, J is 1 now, so I'll.
So let's do it together. So I have H 0 of 14, correct? Is what? Is 1. So this is occupied. I want to do what now? H1 of 14. What is H1?
2.
So let's do it step by step. So it's what? It's HK, which H0 of K. So that's 1, correct? Plus what? J squared. That means going to be 1 squared. Mod 13. So that's 2 mod 13. So what's going to happen?
Gonna go check it number 2, and it's full of all.
Exactly. So it's going to be 2 again. So I'm going to,
With
sorry.
J is equal to 2.
Now I'm going to move to H2. Who wants to do H2, guys? Thank you, Ryan. Who wants to do H2? The only way for you to digest this is by actually trying it. Okay, there is lots of numbers. Taha.
Basically, you're going with 14. So instead of that, we already have our H0.
Exactly. So that, don't make this mistake, guys. So I don't, when I use this H is fixed. All the time is going to be H0, all the time. So it's not going to be the one before it. Like now I'm doing H2, that means I have to put H1. If I'm doing H3, I have to put H2. No, it's always fixed at H0. That means what is H0? 1 plus what?
Plus, so here J is 2, so plus 4.
So 2 to the power of 2, and then mod
13.
13. Then this going to be 5. What happened here? Second. This is more clear, right? Very good, thank you. So what's next? Is this solved? No, I'm still having collision, yes. Question, or you want to? Okay, go ahead. Seconds. Okay. Go ahead. Okay, so we said H3, right? Of 14, what's going to happen?
The 1 is
1, again, why? Because it's the original one here. Plus mod 13. In this case, it's going to be 10 mod 13. So most probably is 10. And then we're going to be like this. Okay? Now, very good. Where did we have the 14 when we used the linear probing? We had the 14 here. So which one is better? Having all of them next to each other like that, or having like an empty space here, then 14 here? So of course, quadratic problem is going to be better for me if I'm using it. It's going to spread it in a better way. If it's spread in a better way, that means the average number of probes that I'm going to need, it will be less. So that's the idea here, okay? Very good. Any question here that's not clear so we can answer it? We're going to solve another one together, but if there's something not clear, because we have the animation, yes.
To reduce the size of the array, right? So when we increase the spreading, we're increasing the size.
No, the array is fixed. You already decided that I'm going to have an array, for example. Let's bring it back to the students in this class. I already designed this class to only fit 100 students. I designed it. I know that my array can fit only 100. Now, when I'm choosing this, I'm going to choose it that the key will be mod the length that I already chose, which is 100, for example. So if I have mod 100, that means it's impossible to be more than 100. That's the idea of modulus. Okay, so no, it's not going to be more. Yes, right.
If you're adding stuff into your hash table,
Mm.
and eventually the load factor or eventually gets too full, you just give up and make a new one, right?
Yeah, usually that means you didn't design it in a very, very good way. Then, of course, you want to do a new one. Yeah.
So that's also creating, it's just like creating an array, like okay.
Yes, yes. So that's why, again, I said usually we're going to see at the last slide here when it is a good, when it's a good, when it's good to actually use hash tables, and which cases, which applications we're going to check it. So very good. If I want to find 14, the same idea here, guys. I inserted 14 using the hash function. So if I want to find 14, I'm going to use the same hash function, correct? Okay, so what's going to happen now? If I do 14, I'll do 14 mod 13 is going to end up with what? With 1. I come here. What's happening in your code is that you're saying, okay, is this value inside index 1 equal to the key that I have? No, it's not. So continue do the next probe. So now I'm going to do the next probe. And then which will give me, I think we said it's going to be 2, I think. And then we're going to do another one, which is 5. And then I do the 4th. So how many probes I did? 4 probes. In the exam, if I ask you how many probes you need to find 10, you're going to tell me 4 probes. Okay? Not like probe 10. Probe 10, that means just like this is the index or the key that we're having here. No, the index, sorry. It takes 4 probes to find 10. Okay? So now, if I want to delete 5, we talked about it last time a bit. We said I want to delete 5. So what's going to happen? If I delete it, what should I put in the place of 5, Ralph?
Special value.
Exactly. Like a Boolean thing or like a flag or something. We said that means so we can know that I deleted something from here. So if I want to search, I'm not going to stop. So let's take a look. So I'll put something like available. So now when I'm searching for 14 again, I'll arrive here. So I'll do 1, 2, and then I'll arrive here. If this is null, if this is empty, what's going to happen? My program will think that I didn't find 14. So I'll stop. So I'll break the loop. So that's why I need to have something like this. So in the coding, when you're doing the coding, you're going to say if it has a value or it has available, continue. Don't stop. Else, if it's null, stop, break the loop. Tell me unsuccessful search, for example. Okay, so that's the idea behind the available. So I want to find 14, probe 1, probe 2, 5, and then 10. Okay. Again, this is quadratic probing. You'll see it's better. We had 5 point something. Now the average is 2.7. But we're still having problems, right? So if I want to have something better, I'll have double hashing. What is double hashing? Let's look at it. This usually scares students in the exam. So pay attention a bit. If you follow the slides, you're not going to confuse because it's a bit overwhelming if you see it like this. The idea here of double hashing that I'm going to have 2 hash functions, two hash functions. I'll start with the first one. If I'm having a collision, I'll go and do the second one. Okay? Sorry, this is the first one here, HK, and the second one, it's DK. Now, this one is called what? Quadratic double hashing. So this is the normal double hashing with J. This is quadratic double hashing. Okay? So let's take a look. So usually, you will come up with 2 functions, 2 hash functions, HK and DK. In this case, we chose HK as K mod 13, and then DK as 7 minus K mod 7, okay? These are given to you. If you're doing your own hash maps, you design these things. But in the exam, of course, it's given to you. So you chose these 2. Now, guys, I made this to just make it easier on us to calculate. you're not going to do DK unless it's needed. So if you focus with me for a bit, I want to insert 18. Which one I should use, HK or DK? HK, all the time. That's my primary hash function. Clear, guys? Primary hash function is the one that we always start with. So in this case, it's going to be what? 18 mod 13, that's 5. I don't touch the DK. So that's 5 here. Now I want to insert 41. 41 mod 13 is 2. I don't have any collision. I don't touch DK. So that's 41. Now 22, the same thing. 22 mod 13 is going to be at 9. I don't touch the DK. Now what's going to happen? I have 44, guys. 44. 44 mod 13 is what? Is 5. Is 5 occupied? Yes. In this case, I don't use the HK. Okay? I have the HK, but I don't use it. I'll use the double hashing function, which includes both DK and HK, both of them. So what's going to happen? This is occupied. So I'm going to use this one. It has the HK and the DK. In this case, what is my HK, guys? For 44, what is my HK? 44 mod 13, 5, correct? So that's 5. Plus, what is my J? 1 in the first one. So that's 1 times DK. What is my DK? It's 7 minus 44 mod 7. It's going to be what? Also 5. If you do the calculation, it's going to be also 5. This time it's going to be 5. So that means it's going to be 5 plus 5 mod 13, which will end up with 10. That's why I'm going to have the 44 here. Did you get the idea? We'll do another example. Okay? Yes, ma'am. Here, these are given to you. These are 2 functions given to you.
Well, it does have to do with the size of the array, or is it just?
No. Okay. So the functions, you create them. So if you're designing your own hash functions for having a strong password, you come up with these hash functions. It's up to you to do whatever you want. The harder the math it is, the harder for the hacker to figure this out, right? So these hash functions, you design them. Like I cannot tell you this is 7 because of this, because someone chose this. This 13 here, yes, this 13 is the length number. So that's the simplest hash function. The simplest hash function, usually the minimum hash function that will be good enough is usually doing the key modulus the length of the array. That's the simplest one.
Strategy to choose. I just want to remember.
You're not going to choose it here. If you're designing your own, if we're having a class of designing hash functions, there will be strategies, of course, but we're not covering this in this class. There will be encrypting and all of these things. Yes, there is, of course, there's lots of strategies. But here, we're saying, I'm giving you these 2. Now, what you need to know is, as I said, the simplest one is the key modulus the length, which is this one. And then the second one can be anything. Okay, guys? Very good. So in this case, any question before I move to the next one? Let's do another one. Yes, just.
Unrelated, but just a math question. How come D of 3 for 44 is 5?
Do it. Get the calculator and do 44 mod 7 and then 7 minus this and check it.
44 mods 7 minus 4. Oh,
Yeah. So this, like this.
DK would be 2. 4 mod 7 equals 5. 7 minus 5 equal 2. I think it's 7 minus K mod 7.
There will be a mistake then, most probably. So for now, I'll check these numbers. For now, assume these are the numbers here are here. Okay, let's focus on this for now. Okay, we're going to check the numbers later on. So it'll be like this, guys. K mod 7 and then 7 minus something. Okay. So let's do another one. I'm going to do the 59. 59 is clear. Which one I'm going to use, HK or DK for the 59? Which one? HK, always the primary function. So Then for the 32, the same thing. Now I'm going to go for the 31. What's going to happen with the 31? Let's do it. So I have 31 mod 13 is going to be what? 5. Is 5 occupied? Yes. In this case, what's going to happen? Who can tell me? Raise your hand. So if you want to solve this, you want to insert 31 based on the double hashing function. Yes.
5 plus 4.
So go slowly so everyone will understand what you're doing. So what are you doing? Why 5? So we're going to use the HK here, which is 5, and then plus J is what in this case? 1. And then DK is what? 4. How did I get the 4? From this one, right? 7 minus K mod 7. Okay, very good.
Why is J1 this way?
Sorry?
Why is J1 this way?
Because when we have this collision here, we're going to assume this is the H0. And then we continue with J1.
We're trying to add an index 5 using H twice, right?
No. So if I'm using this all the time, okay, if my first try is H0, think about it. My first try is H0. If I have J as 0, I'll end up what? Using only HK. So that's my first try. That's my H0.
Okay.
So that's my 5.
Yeah, that's when we did 18, right?
Which 18?
When we started 18.
Has nothing to do with 18. Now we're trying to do a 31.
But we have a collision with 18, right?
No.
It's 5.
So let's do it slowly. I want to answer 31. Okay? I want to answer 31. I'm going to start right away from this one. I want to start right away from H0 here. If I have H0, J is what?
0.
0. So I'm deleting all of this. That means my H0 is going to be HK. That's why I'm starting with HK alone the first time. So that's why K mod 13 is what? It's 5. So 5 is occupied. I should go to H1 after that.
But H1 is not there.
No, H1, I need to calculate H1. So what is my HK? 5 plus, now J is what? 1 times what? DK. What is my DK? 7 minus K mod 7. It's going to be 4. So that means times 4. And then mod 13. That's how I'm going to get my answer. So 9 mod 13. Okay? So these are the steps that's taking, guys. So in this case, I have HK 31 mod 13, that's 5. I'll have my H1 is what? Is 5 plus 1 times 4 mod 13, that's equal to 9. Mod 13, that's 9. So it's occupied again. So what's going to happen now? I'll need someone new who's still trying to figure it out. It's not clear. Yes? H what? 2. H2. Very good. If I'm doing H2, what's going to happen? HK is 5 plus J is what in this case? 2 times DK is what? 4. So as you can see, guys, HK and DK are fixed. Okay, they are always the initial one that I'm going to try. Okay, they are fixed. And then I'll do mod 13. So that's going to be what? 0. Is 0 empty? Yes, I'm going to put 31 here. Okay. If you know the steps, if you understand the steps, it's going to be super easy to do it in the final. Because the math is not a big deal. The math is just math. You just need to understand the steps. What do you mean by steps? That means which HK and DK are we going to use? The original ones or the previous ones? So these steps are very important. So let's now solve a few things together. Before we do that, the same thing. If I want to remove something, if I'm removing 22, I'll start with the primary clustering, primary function, and then I'll do it the same exact example here. I put available, and we do it. Now this is going to be a bit better, the double hashing, and now this is my conclusion. So we already covered this. We said it's very important for you to know that the worst case is of n. This is very important for us. What's going to happen? The expected time, it's of 1. As I was telling Riley, usually hash tables are very good for small databases. If you have a very big database, it's not going to be useful. Why? Because then you'll have to have the hash table big. It's not very useful. Also for compilers, because you need something closer to the hardware and the browser cache. Now let's do these things together, guys. I'll do this first, and then I'll let you do the other ones on WooClap. So in this case, can you see this clear? Okay. So suppose that, how do I read? These are from finals and midterms. How do I read the question? Suppose the length of a hash table is 11, and the hash function is this one. Do you see? I give you usually the hash function. I'm telling you the hash function is key modulus 11. And then I'm telling you there are only 4 nodes in the table. These 4 nodes. And the remaining positions are empty. If the conflict is handled by linear detection method, which is the linear probing, what is the node address of 49? So the first thing, don't get confused, don't freak out. You say, oh, you didn't give us a table. But can we do the table? Let's do the table. So if I'm having the hash table is 11, that means I'll just have 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you build it yourself. And I'm telling you, H15 equal 4. Which one is the index? Which one is the key? 15 or 4?
4 is the index. 15 is the key.
Because we have maximum index 11. Okay, so it's always here. Look at it, H key. So the one inside is the key. So I want to insert key 15 and index 4. So that's 15. Now H38 is where? 38. H61 at 6. H84 at 7. First, even if I'm not giving you the table, you can build the table. Now, what is the question? If the conflict is handled by linear detection method, what is the node address of 49? That means I want to insert 49 in this table. So the first thing that what do I need to do? I need to use the hash function for 49, correct? So which hash function I'm going to use? The one that I'm giving you. So in this case, I'm going to have what? 49, so it's going to be H49 equal 49 modulus 11. I think it is going to be 5 or 4? 5. So if you're doing linear detection, linear probing, you can use the function, correct? That we said. What is the function? HK plus J mod blah, blah, blah. But because it's linear, there's no need to waste your time. It's linear. So if I'm here, that means I'm only going to go linear-wise, so I'm going to end up where? Here. So the answer will be 8. Because it's linear, just jump, so you don't waste your time. Is this clear? Very good. Now let's do the other ones together. So do you need access again to this, or you're able to go right away? Okay, I have this question. I want to insert 14. My hash function is key mod n. N is what? Is the length of the table. And I'm doing quadratic probing. Okay? My first step is H14 equal 14. Mod 13 equal 1. I found position 1 and the hash table is occupied. What is the next step? So I found that it's not empty. That means I need to use the collision resolution. In this case, what is the collision resolution? Ralph. J square. Exactly. Mod 13. So that's the quadratic. Okay, in this case, what is the right thing? H1 equals 14 plus 1 mod 13, or is it 1 plus 1 mod 13? Which one? So Ralph is saying here, what is the equation? The equation is HK equal HK plus J square. The first one, J is going to be 1. So 1 square, that's 1. But which one I should choose, 14 or 1? 50-50. Okay. Very good.
Okay, now.
Very good. Okay.
Yeah.
So let's see which one is the correct one, guys.
Governors, whoever decides. Only left stands there. Keep them on.
Which one is the correct one? That's my quadratic probing. I have HK and J square. In this case that I asked you about, which is this one. So if we look here, we said it's going to be what? 14 mod 13 equal 1, okay? So 14 mod 13. So my first HK is here is 14 mod 13, and that's what equal to what? To 1. I'm asking you, when we use this function, do we put 1 here or we put 14, which is the key? That's what I asked. There is no reason to put the key, right? So we're going to put the HK, which is 1. Is this clear? Clear? Okay. That means the answer is 1 plus 1 mod 13. Okay, so let's continue. Now let's take this question from a final. Consider the following hash table where insertions are done using the hash function HK K mod 7, and collisions are resolved with quadratic probing, okay? So which key is going to be the last to be inserted? How can I do this? Definitely, but by not just looking at it. Okay? If you look at it at the exam, you're not going to guess it. So what do I need to do? I need to solve it. So I'll ask everyone to start solving it. A piece of paper or on your iPad. So start solving this. You need to figure out which value 15, 1, 8, or 5 was inserted lastly. Who can help me with the steps? Like, what do you need to do just to help your friends? So what do you need to do? How do you solve it in front of you? What are you doing? James.
All you can do is that you can find the modulo.
Very good. So as a first step, I know that I have these and I have the hash function. So let's try 15 mod 7. What would it give me? And then the same thing for the 1, for the 8, for the 5, and I should be able to conclude. So 15 mod 7 is what? 1. That means 15 is the last one inserted. It's the first one. So it's done. Let's do 1. 1 mod 7. 1. Is 1 taken? Okay, I want to do a quadratic probing. So what would be the next one? 2. Okay, is this the last one inserted? No, because I found this. Okay. Now I need to do 8 and 5. Let's try 5. 5 mod 7 is what? 5. That means, is it the last one inserted? No. I don't know. Maybe no. So let's do the 8 at the end. 8 mod 7 is what? What? 1. Okay. 1 is taken. So I'll do it again. For the quadratic, that means it's going to be what? 2. Correct? It's not on 2, the 8. That means 1 was before 8. Correct? So that's how you deduce, and then we're going to do it again. It's going to be at 3. I'm going to show you 1 second. Let me show you. So let's do it here. So look at it. 1 mod 7 is 1. 15 mod 7 is 1, first probe. And then we said, I'm going to do the 8 mod 7 equal 1. If I'm doing 8 mod 7 equal 1, that means that's 1 here. Correct? That's 1. Then plus 1, why? Because 1 square, I'll end up with 2. 2, 8 is not at 2. That means I know for sure that 1 was inserted before 8. In this case, I'll do this again. 1 plus 2 to the power of 2. That's what? 5 mod 7. That's 5. Also, it's not on 5. That's how I know that 5 was inserted before. And then it's going to be at 3 at the end. Okay? Very good. Okay, let's do the next question. Consider the following hash table where insertions are done using the hash function hk equal k mod 7 and collisions are resolved with linear probing. Okay, I want to know the average number of probes. To be able to calculate the average number of probes, guys, what do I need to do? I need to calculate the number of probes for each key, then I'll divide by the number of keys. So technically, I'll do 15 mod 7. We already did this, and then we do all of them, and then we'll add them. Okay, because we don't have much time, I'll show it to you right away. So what's going to happen here, guys? So look, I need to calculate the number of probes. For key 15, we said it's going to take us only 1 probe, right? Why? Because we did 15 modulus 7 equal to 1, and right away we saw it's here at 1. And then for key 5, the same thing. We said 5 modulus 7, it gave me 5, so that means it took me only 1 probe to be at 5. So that's very good. Then for key 1, it took me 2 probes. For key 8, 3 probes. I have 7 probes. How do I calculate the average? It's going to be 7, not divided by the length of the array, divided by the number of keys inserted. How many key I have here? I have 4 keys, 15, 1, 8, 5. So 7 divided by 4, that's 1.75. So the answer would be B. Okay, very good. So we'll do the last one together, and then please watch the tutorial video of the hash table. It's detailed. And then if you're still not understanding, go actually with Kavari on Monday to the actual tutorial. Okay, don't leave this tutorial till before the midterm, the final, to watch it and then figure out that, okay, you still don't understand it. So now the same exact question, I'm saying I want to insert 2. Okay, guys, so I want to insert element 2 in the table. Still using linear probing. So I'm going to do 2 modulus 7 is going to give me 2. So 2 is occupied. If I'm using linear probing, we're just going to add 1 plus 1, right? So plus 1 here is still occupied, plus, so I'm going to end up here at 2. Now then you're asked after this, so after inserting 2, you want to search how many table positions must be probed until you conclude element 3 is not in the table. So what are you going to do? Again, 3 modulus 7. Why we're using this? Because the hash function, k mod 7. So it gave me 3. So I'm here. So that's my first probe. Be careful. The first one is your first probe. A second probe, a third probe, and also a fourth probe here. You need to actually do a fourth probe and find that it's empty, so you can say unsuccessful search. It's not 3 probes, it's 4 probes. Clear? Any questions about these, Raf?
If it was successful and they're asking us how many probes it still takes, it's still 4?
4, yeah. If you have, let's say, 3 here, also 4 probes, because you have to come to this and check it. That's what it means. Yes, Bas.
Can you put these questions on the break?
Yes, of course. They are. I'm going to now. It's already in the slides. I just hide it. It's just hidden. I'll just post them. Good. Yes.
We have a gap already in that
No. So look what's going to happen. A good question. If I don't have 2 here, okay, and I want to do this. So I did 3 modulus 7. It gave me 3. So I'm here. So that's my first probe. I don't have 2, okay? So how many probes is going to take me to figure out that it's unsuccessful search? 2, because the second time it's going to be here and this is empty, it's done. But if I had 2 and then I told you here, I inserted 2 and then I deleted 2, yes. So you're going to put available and then it's going to be blah, blah. So the same thing as the slides, okay? Any other questions, guys? Still have 5 minutes, 10 minutes, questions? Good? Okay. Again, I'll post these. The tutorials are very good. The tutorials are actually from the past finals and midterms. Like we're actually solving midterms and final questions.